Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I'll be continuing to work through the 2020 Board of Studies Extension 2 trial paper. In this video, I'm up to question number 3. Originally, I was asked by a student to answer question 11D of this paper, and then after working through that, they asked if I could go back through and work through all the other questions. The way they described this paper was that none of the questions are trivial. In other words, there's no easy marks to gain on this paper. Even the early questions are fairly tricky, and so they saw the value in me working through all of the questions. So here I am up to number 3. If you find my explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. So question 3 tells us to let fx and gx be real valued functions over the domain x greater than or equal to 0. We're told to suppose that fx is greater than or equal to 0 and the limit as x goes to 0 from above of fx is equal to 0. And also the limit as x goes to 0 from above of gx is equal to 0. Further, suppose that the limit as x goes to 0 from above of fx to the power of gx exists and is equal to L. Which statement best describes the value of L? So we've got A, L is equal to 0, B, L can be any non-negative real number, C, L is equal to 1, and D, L can be any real number. Okay, so to help work through this question, I've drawn up an axis here because I think it will be helpful to visualize what we're dealing with. And I've written up the 4 options that we need to choose from because as a multiple choice question, at the end of the day, we can just use a process of elimination to try and cut out what we know can't be correct and hopefully end up with what is the correct answer. So in terms of what we're dealing with, we're told we're concerned with the x in the positive domain. So we know we're dealing with x greater than or equal to 0. And we're also told that the function fx is also greater than or equal to 0 in that domain. We're told that the limit as x goes to 0 from above, or in other words, if we're coming towards x equals 0 from this direction, as opposed to this direction, that limit of fx is equal to 0. And similarly, the limit as x goes to 0 from above of gx is equal to 0. And then finally, we're told that the limit as x goes to 0 from above of fx to the power of gx is equal to L. And it's this value L that we're concerned with, or at least the nature of it. We're not going to find what L is, but we want to know, we want to make a conclusion about it. So in terms of what this looks like, I think maybe the first thing to sketch up will be y is equal to fx. Now we're not given the function x, but I know a few things about it. I know x will be positive, greater than or equal to 0. And I know fx will be positive. So I'm just going to draw something like this. It really doesn't matter. But I know that as x gets closer to 0, the function fx gets closer to 0. Now, what I'll also do is draw a curve for gx. And again, we're not given gx, but I mean, there's a few ways we could think about gx. Maybe gx also looks something like this. I mean, we know that gx, as x comes to 0 from above, gx will also come towards 0. So this is one possible way that gx could look. Maybe if I pick another color, it's also possible that gx could look something like this. I mean, we're not told that gx is always positive like we were with fx. So, you know, there's a bit more possibilities there for gx. But I think at the end of the day, what we're really kind of dealing with here is fx to the gx is going to kind of involve what is definitely going to be a positive number, because fx is always greater than or equal to 0, to the power of maybe it's a positive, or maybe it's a positive number to the power of a negative if we've got gx down here. Now, what might be tempting is to think, well, the limit of fx is 0, so fx cuts close to 0, and so does gx, so really what we're dealing with is 0 to the power of 0. And therefore, the limit would be equal to, and this will depend on what you think about 0 to the 0. You may be tempted to think 0 to the power of 0 is 0, because 0 to the anything is 0. Or you may be tempted to think that 0 to the power of 0 is 1, because anything to the power of 0 is 1. Now actually this is fairly controversial. I think maybe I describe it as conventional wisdom might suggest that 0 to the power of 0 is undefined. That's one way to think about it, at least when dealing with limits. And then others may argue that 0 to the 0 is 1 when dealing with kind of numbers outside of the context of limits. Regardless of where you get to, in our case we are dealing with limits, and therefore 0 to the 0 is actually undefined. So we can actually cut out A and C right away, because those are saying that L is 0 or 1, and I think they've been put there to try and almost trick you into thinking one of these must be applicable. But actually we're dealing with limits, and in that context for sure 0 to the 0 is undefined. So we're going to cut out those. Those aren't valid ways to think about L in this question. So that leaves us with just B and D. Now, at the end of the day, if we've got a positive number, taking that to the power of anything, whether it's positive or negative, will always give a positive number. Like 2 to the power of negative 1 is still a positive number. All you're doing is putting the 2 in the denominator. There would be 1 on 2. So actually, the difference between option B and D, L is any real number or non-negative real number. So the key difference is, can L be negative? And the reality is it can't, because we're dealing with something that's positive to the power of something else. So actually, we can cut out D, and we're left with B. We need this criterion that L must be non-negative. So that's how I think about this question. I'm not sure whether that's necessarily the most robust way, and whether I've necessarily fully grappled everything to do with this limit and what it's about. But actually, from an exam taking perspective, I think it's a valid way to kind of get to the right answer. We're not going to get 0 or 1, and the way you can think about it, whether it's right or wrong or controversial, is just to go 0 to the 0 is undefined in the context of limits. And then it becomes a fairly simple choice between, can this limit be negative? And the answer is no, because the base is always a positive number. Fx is always greater than or equal to 0. So hopefully you found that helpful. Hopefully that's given you one way to think about this. I know that there probably are other ways to deal with this and get to this right answer. Definitely don't doubt that. But this is just the way I think about it. So hopefully it's given you one other perspective that can maybe help you grapple with these kinds of questions. So there you have it, and tick boom.